Hello students, in previous classes we have gone through all the four types of the inverse trigonometrical problems. Now this is the time to take up the doubts, and few of your friends have sent me few problems and I am just taking that, I am reviewing their doubts. Here the answer for response for the first question. Tan inverse 2x upon 1 minus x square plus cot inverse 1 minus x square is equal to pi by 3. How will go for? Simply this implies, and we have to solve for the x, this implies tan inverse 2x upon 1 minus x square we write, and reciprocal of the tan inverse is a cot inverse, this is 2x upon 1 minus x square. This is equal to pi by 3. And as earlier we have gone through, 2 tan inverse x has a few results, and this is the result for 2 tan inverse x, that is tan inverse 2x upon 1 minus x square. Again this is 2 tan inverse 2 x, and that is pi by 3. Now clubbing both, it will be 4 tan inverse x is equal to pi by 3, and it will be tan inverse of x, and that is pi by 12. Therefore x is equal to 10 pi by 12. Now 10 pi by 12 is 15 degree, and this is very easy to get it, that we can find out by 45 minus 30 degree, and we can calculate it 45 minus 30 degree upon 1. So this is 15 degree, and 15 degree can be written down 45 minus 30 degree, and 10a minus b formula can be correlated here. This is 45 degree minus 30 degree, 1 plus 30, 45 degree. That is 1 minus 1 by root 3 upon 1 plus 1 by root 3, and that will give you the root 3 minus 1 upon root 3 plus 1, and we can rationalize it, and by doing so we will have 4 minus 2 root 3 upon 2, and finally it will be 2 minus root 3. So we got the value for this question and the x for this one. Therefore x is equal to, this is 2 minus root 3. Now I am taking the second column, which is given to me for the solution, and this is cos of tan inverse x is equal to sine of cot inverse, this is 3 by 4. How will we deal it? We can write it cos of tan inverse x is equal to, we can change in the complementary, pi by 2 into cot minus cot inverse 3 by 4. So we can write sine as a like this. By comparing both sides, this is tan inverse of x will be equal to pi by 2 minus cot inverse of 3 by 4, and that will give you cot inverse of 3 by 4 is equal to pi by 2 minus tan inverse x, and pi by 2 minus tan inverse is nothing but it is cot inverse x, and by doing so, therefore x will be 3 by 4 in this case, and this is the way we can solve the problem which is given to me, and I am responding for the questions, and this is nothing but very easy to go for. Now third example. Now I am taking the third problem. This is tan of cos inverse x and sine of cot inverse 1 by 2. How we deal it so that we can solve for the x? So we have taken the cos inverse x is equal to t, cos t is equal to x. We will make a triangle. By making the triangle, we will find out the base, hypotenuse and all, and we'll convert it in terms of the tan. And the same manner we'll write down the cot inverse 1 by 2 is equal to 2, tan inverse 2 is equal to 2, and tan t is equal to 2. In this also we'll make it in the 2 and 1 the base, and perpendicular base we'll find the hypotenuse, and we can define the sine inverse. So both the side we have the conversion, and after converting the angle will be remain there, and that will be root under 1 minus x square upon x, and root of 3 by 2, and not angle, you can say like the variant will be there, And this is 1 minus x square upon x square upon 5 by 4, squaring both sides. This is 9x, 5x square is equal to 4 minus 4x square, and that will be 9x square is equal to 4x square is equal to 4 by 9. Therefore, x is equal to plus minus 2 by 3. We will go for verification also, and the value required will be taken for the answer. This is the way we can go over the questions related with the solving for x. There are a few more problems we are having. You can respond it to me, and definitely I will give the answer. But this chapter is over. We have completed the inverse trigonometry. Shortly, in the very next class, we will start the differentiation, and after a few prior to that, shortly we will conduct the test for this inverse trigonometry. Thank you for today. God bless you.